Dear students, today's topic is UPGMA, which comes under Module 4 for the course CS465 Bioinformatics. What do you mean by UPGMA? UPGMA is abbreviation for Unweighted Pair Group Method with Arithmetic Mean. It's a method that is used to construct phylogenetic tree. What do you mean by phylogenetic trees? Phylogenetic trees are trees that will shows the graphical representation of the evolutionary relationship among three or more genes or organisms. The phylogenetic trees can be constructed using two methods. One is the distance matrix method and the other is a character-based method. So the UPGMA comes under distance matrix method. Let's go into detail. So for the tree construction using UPGMA, we have to prepare a distance matrix. Once the distance matrix is prepared, then repeatedly do two steps until there are only two clusters. So what are those two steps? Step 1. Cluster a pair of leaves or taxa by shortest distance. And step 2, how to recalculate a new average distance with the new cluster and other taxa and make a new distance matrix. So these two steps can be explained by explaining an example. So consider an example. Use UPGMA to reconstruct a phylogenetic tree using the following distance matrix. So you have given a distance matrix. From the distance matrix, you just go do the two steps, step 1 and step 2 repeatedly, and the two clusters are there. So this distance matrix, it shows it has a number of rows and columns, and each rows it contains, for the first row it contains species A, B, C, D, and E. And also the first column contains the species A, B, C, D, E. And you can see that some values are there in each cell. Actually, these values represent the distance between the species. So let's take the first cell. Its value is 0. That means the distance between A species and B species is 0. While taking A and species A and B, the distance matrix, it given that the distance between the species A and B are 20. Like that, we get some distance between the species. So this forms the distance matrix. So for evaluating or for the construction of a phylogenetic tree using UPGMA, we will have a distance matrix, and we have to do those two steps repeatedly until we get two clusters. Okay, thus we can construct a phylogenetic tree. So by evaluating this example, or by solving this example, it's understandable how to construct a phylogenetic tree. So let's go into detail. So what is our first step? Step 1 is cluster a pair of leaves or taxa by the shortest distance. So from the given distance matrix, we have to find which species or taxa have the shortest distance. So let's take the given distance matrix. So while go through each cell values, you can see that the distance between the A species and B species is 20. While comparing all other, we not considering 0 values. So by comparing all other values, we can see that 20 is the smallest value. So we take 20. That means we can group this A and B together. Clear? So then step 2, what is the step 2? Step 1, we find the smallest distance. Okay, fine. The step 2, we have to cluster or recalculate a new average distance with new cluster, another taxa. And we have to come up with a new distance matrix. For that means the species, we group the species A and B together and rest are in the remaining columns. So while grouping A and B, the part of a phylogenetic tree can be constructed. It's only part. That means I group A and B, and the distance is 20. Okay, thus I can construct as part of the phylogenetic tree. So again, we have to fill this matrix. Okay, how? That means we have to recalculate the matrix. How? So step 2 is recalculate a new average distance with a new cluster and other taxa and make a new distance matrix. Let's see. So filling up the distance matrix. So you know that from the first distance matrix itself, we know the value between C and C 0, and C and D is 40, and C and D is 50, D and D 0, and D and D is 30. These all are given in the first distance matrix itself. And the unknown values are the distance between A, B, and C, the distance between A, B, and D, and the distance between A, B, and D. So we have to find out the distance between A, B, and C, A, B, and D, and A, B, and E. How? Let's see. So that we can apply an equation. So the distance, new average distance between A, B, and C is, I have to find, can be represented as D of A, B, since we group A and B, because we find that from the distance matrix, distance between A and B among the other species is smallest one. So we group it. And we have to find the distance between A, B, and C. So that is equal to the distance between A and C plus distance between B and C. That is the distance between A and C plus distance between B and C divided by 2. So distance between A, B, C is equal to 1 by 2 of distance between A, C plus distance between B and C. That is the distance between C to AB. So our aim is to find distance between C to AB. That is distance between A to C plus distance between B to C divided by 2. So what is the distance between A and A to C? So taking the first matrix, what is the distance between A to C? 60. Then next B to C. So B to C is 50. So 60 plus 50 by 2, that is equal to 55. So I can fill the distance between AB to C as 55. Like that, we have to calculate the distance between AB to D and AB to E. Okay. So the new average distance between D to AB. D to AB means distance between A to D plus distance between B to D divided by 2. Let's see, what is the distance between A to D? A to D is 100. That is written here. And distance between B to D. B to D is 90. That is written here. So 100 plus 90 by 2 will give the result 95. So you can fill the table with position D and AB is 95. Like that, we have to find the distance between E to AB, that is distance between A to E, plus distance between B to E by 2. A to E is 90 and B2 is 80 by 2 will give 85. So like that, we can fill this distance matrix, new distance matrix. So from this distance matrix, you again repeat the steps. So we did the step 1 and did the step 2, and we have to repeatedly do these 2 steps and then get 2 clusters only. So again, you see it's not this matrix is not with 2 matrix more than 2 clusters, more clusters are there. Oh, sorry, more species are there. So what we have to do? Again, we have to do the step 1 and step 2. So what is the step 1? Again, we find out the species with smallest distance. So while evaluating each cell, we get this 30, that is distance between D and D is the smallest. So I group D and D with the distance 30, which is another part of the phylogenetic tree. Then we have to do the step 2. That means we have to recalculate or construct a new distance matrix. So I group B and D. So our new distance matrix will look like this. Already AB is grouped, then C is there and B is there. So we have to fill this matrix. How? Using the same equation, we can fill this table. So the distance matrix 3, that is AB and AB 0, and C to AB we know 55, C to C is 0, and we have to find the values of distance between AB and BE and C to DE. So the average distance between AB and DE is 95 plus 85 by 2. How you get 95 plus 85? So the just previous distance matrix have to take. The just, that is this matrix. Last generated distance matrix we have to take. So the distance between that means distance between AB to D, AB to D, and AB to E. So what is the distance between AB to D? That is 95, and AB to E is 85. That's why 95 plus 85 by 2, you will get the result 90. So I fill this table. Then find out the distance between C to DE. How? The same equation. So I get its value is 45. Clear? So I can fill this matrix 3. Then again you have to check which one is the smallest distance. Again, while evaluating the distance matrix, I get the 45, that is distance between C and DE is the smallest. So I can group C to DE. So I can place C in between AB and DE, and I draw a line from DE. Since I group C to DE, the distance between C to DE is 45. I marked it. Again, I have to reconstruct the matrix. So while reconstructing, the matrix will look like AB and CD, AB and CD, its value. AB to AB is 0 and CD to CD is 0. And I have to find the distance between AB to CD. The distance between AB to CD is, while considering this distance matrix, AB to C plus AB to CD. So AB to C is 55. That is 55. And AB to DE is 90. So 90 plus 55 by 2 equal to 72.5. So I can fill the newly generated distance matrix with these all values. And you have to check whether the distance matrix, newly generated distance matrix is with 2 or more species, with 2 clusters. So here it contains only 2 clusters. So that means we come up with the termination condition. So we can stop here. So I can group this CD to AB with the difference or the distance 72.5. So since this distance matrix contains 2 clusters, we can stop the calculations. So from the given UPGMA or from the given distance metric using UPGMA, can able to construct the phylogenetic tree. So this is a phylogenetic tree based on the given distance matrix. I hope you understand the topic UPGMA for the tree construction, for the phylogenetic tree construction. Thank you.